Hi, this is Brad Cole with Digi International, and today I'd like to talk to you about hardware-enabled, software-defined. So one of the things that we've realized is hardware is becoming more commoditized over time as software plays a more critical role. So first, hardware was the primary focus. It was a way to gain access to things and get data to a central location where it could be analyzed. So that's still important, but the focus has shifted away from specifically hardware to capabilities that would be software enabled on the hardware. So you want to do things like edge analytics, machine learning, and more sophisticated things with your devices. So traditionally, hardware engineers' focus would be on requirements that they were most familiar with. So things like price, footprint, how much memory, how much flash, and things like that. While those things are still important, IoT is changing the landscape. So let's take a quick look at the return on investment for IoT. So the traditional approach would show that return on investment equals the time value of future profits over your investment and cost to deploy. So profits would be maximizing your production gross margin, reducing your investment or minimizing your investment. So having a small an expense footprint for your engineering costs. And then you live with the time that your product is going to live in the market and how many of those you can sell. So let's go through a couple of what-if scenarios in the IoT space. So what if you had a solar farm and you had sun tracking solar panels and you discovered an issue with them, or you discovered a way to make them more efficient? Wouldn't it be best if you could easily push an update out to those solar tracking panels and update the logic remotely? Another what-if scenario, what if you discovered new characteristics or changes that you need to implement for floodwater patterns to be able to improve pump efficiency? So let's say you were able to determine a better way to pump, how long to keep the pumps running, how often, and you had a way of basically staying ahead of storm surge situations. So wouldn't it be great to be able to deploy those changes? Another kind of utility what if, in the case of a lift station, what if you could keep track of the efficiency of the pumps and predict when one is about to fail so you could avoid having a real big mess on your hands? So if we go back to the IoT model, or take a look at it in a different way, IoT kind of tweaks that model. So you still have your initial development costs, you have your deployment costs, but the investment is going to continue after development and even after deployment. Your adoption, as always, is going to deliver profit, but your adoption over time and your adoption to a subscription service can deliver even more profit. But you could experience churn. You know, you've got customers who are going to lose interest, or they might not see enough value in the subscription, so you'll experience some churn. So the key is sustaining value by continuing to add functionality or adding value so you can eliminate as much of that churn as possible, and that really delivers ongoing recurring value. So a really good example of this is a car manufacturer who delivers new functionality, new features to customers over time. So once you bought the car, you may not have a fancy onboard autopilot system, but Tesla, for example, was able to deploy major software updates that really update the characteristics of the car by just deploying a software update over the air. So if we look at the traditional IoT solution, it's becoming increasingly more important to consider aspects outside of your normal distributed system. So can you change the characteristics of that system or of your deployed assets over time? Can you make them more intelligent? Can you change the intelligence of those distributed devices? So then if we look back at the ROI model, you're designing for development. Then you want to make your users and added value a priority, and then that is what's going to sustain your value over time, and you really do want to prepare for the unknown. And so that brings us to kind of the future built concept. So the what if scenarios are a reality. Some of those are taken from real world customer cases. And it's no longer sufficient to just deploy a solution that has functionality based on today's needs. You have to think about the unknown needs of tomorrow, or at least plan for solving unforeseen problems that may not arise today. So let's take a quick look at the IoT stack as a whole. Managing an IoT stack is very complex. There are many options available for things like cloud analytics, edge compute, machine learning, et cetera, et cetera. So what if you want to change any of these components? How are you going to manage all of this stuff? So that's where a device manager comes in. A device manager or a device management application, a successful IoT deployment requires one of these things. The IoT device manager really acts as a quarterback of the IoT stack. So functions that are going to reside in a good IoT device management application would be things like seamless integration with hardware. You want to make sure this is going to be part of your ongoing lifecycle strategy, and so you want to be able to manage constant changes to connectivity, security, and then business logic. So some of the key components, again, as I mentioned, security, the reliability of your deployment, and then getting insight from your deployed assets and being able to control those assets as well over time. So what fits where? So if we look back at the IoT stack, a solution provider needs to manage everything from their application out to their edge devices. And so where Digi focuses is really on the lower edge of the stack, where device management and devices and connectivity reside. We partner with others to handle the upper part of the stack. So Digi manages the full extent of the stack, but we utilize partners to handle things like analytics, data management, machine learning, et cetera. So you need an application approach that provides devices with extensible capabilities. Connectivity has to be reliable. And then you need a device management solution, as we talked about, that can manage that and distribute business logic to those devices, as well as manage the health and security of those devices throughout their deployed lifecycle. And then you need connectors to integrate with third-party applications or third-party cloud analytics, machine learning capabilities. So these connectors can be from cloud to cloud or from device to cloud. The key is you want to have the flexibility to connect however you or your customers want to connect. And this is an example of some distributed edge logic and all of the different capabilities that can reside at the edge and things that you would want to manage from a good fully functional device manager. So if we take a look at managing, another example is edge intelligence like Azure IoT Edge or AWS Greengrass. So if we take a look at some customer examples, EVOQUA, one of our customers managing water, they've distributed a system where they use an XP module that connects cellularly back to Microsoft Azure, and that uses their Azure machine learning to gain insights into the operation of their distributed systems. And so they can determine how frequently you need to replace chemicals or you need to replace systems in the field. So they can determine from the machine learning models how these systems are performing, and they can anticipate problems without having to wait for a customer to call them up saying, hey, my system has stopped working. So they can save customers money, and that also adds value and ensures recurring revenue for them. Another example is oilfield dosing tank monitoring. So you want to make sure that if you've got an unattended oil field and you're sending chemicals into your infrastructure, you want to make sure that your tanks have adequate chemicals, dosing chemicals in them. So this allows companies to monitor these tanks and then distribute or steer the distribution chain appropriately, so that they're not wasting time by sending people out to refill tanks that are half full, or they don't let tanks go empty for any period of time. So they have a really good view of their fully distributed network of tanks out in an oil field, and they can more efficiently distribute those chemicals to them. Solar pump monitoring. So this basically allows you to monitor the efficiency of things like solar panels, how it's distributing the energy, and if you need to send somebody out to perform service. Home energy management. This is an interesting example where companies might be using analytics to determine efficiencies of homes and determine how to maintain the comfort level for a homeowner while reducing their energy costs. So those are just some simple examples of distributed IoT systems that utilize edge intelligence to make those solutions more efficient and provide value over time. So thanks for tuning in. Hopefully this was helpful. We want to welcome you to the future of hardware-enabled and software-defined.